Hello, welcome to the second video, part B of the final Fluent project. For this project, we'll be showing adding a cylinder to the wind tunnel and seeing the effects of a cylinder inside the wind tunnel. I'm not going to be showing the geometry, how I built it, because it's basically the same geometry as the first part, building the wind tunnel. Just for the part B, we added a cylinder in the middle, as you can see right here. And I used some of the lines that I made previously to find the middle of the wind tunnel. I found the center of the wind tunnel, and here it is. And then we did a phase sketch excluding the cylinder so we can have it right here. But yes, that's our geometry for this portion. The cylinder is 1/10 of the height of our wind tunnel. So if I open my mesh, opening the mesh right now, I'm gonna close the design model part. Make sure everything's recording. Here's my mesh. So first thing I did was triangle method, the body of it, then edge sizing. For the circle, I did 500 divisions and I changed my behavior to hard so I can get more concrete data. And I did inflation of the surface and the edge of the circle. First layer thickness of 1.8 times 10 to the negative 4, and we did 100 layers and 1.2 growth rate. If I go over here and I generate my mesh, oh, it's already generated for me. Perfect. We can see our glorious black hole right here, where our cylinder and fine mesh in between. And then I did my name selections. Right here we have the wall, the whole outer surface, the cylinder wall, the cylinder, inlet, and outlet. That's all for mesh. My workbench. Now let's open setup. Left click setup. Did my mesh close? I think it did. Perfect. Make sure we're recording. We are. There, it's open and it's opening. Fluent, double precision as always. Open the program. That should open soon. All right, so now we go to model. Make sure that this is viscous standard K epsilon right there. We go to material, fluid, air. Make sure everything's okay over here. Make sure nothing got changed. Perfect. Close that, go to boundary conditions. We can just left click, double click boundary condition. Everything would be here. The cylinder wall. Our inlet velocity is still going to be 5.625. I hope. It's not. Yeah, we'll just change it. 5.625 right there. And wall should be good. Nothing should be there. Pressure outlet, nothing should be there. Nothing should be there. And cylinder wall, everything should be good here. But just opening it just in case. Stationary, perfect. So now we go to our reference values. I'm gonna make sure this is updated to that. Gonna go to my report definitions. Seems like my one's already there, but I'll do it again. Force drag. I'm gonna get my drag coefficient. It's gonna be important for my calculation of drag coefficient, but that's more for the flat plate part of it. So I got my drag force in there. There you go. We're initialized right now. 25 initialization, correct. Initialized. This shouldn't take too long, but the run calculation is going to take a while, so I'll get back when that's fully done. Took probably an hour. So let's go see the contours. Oh, we already have it pre-made for us. Velocity contour. Boon didn't select all of them. Doesn't matter. Here's our velocity contour magnitude, and it's gonna display something beautiful for us. There you go. Now we can see. Let me zoom into that golden eye right here. Why my computer so laggy? Here we see a wake region where our velocity or our stagnation point right here, where our velocity is 0 and our wake region right here. Beautifully developed and high velocity region right here. But there you go. We have our pressure. I should probably select that one too. Pressure, static pressure, correct. Pressure one. Here we go. Here, it's stagnation point, so that's when our pressure should be equal to atmospheric, and low pressure when the high velocity. Wait, something is wrong. We're in the center, and this is expanded right here, and we also want our CP distributions. Pressure coefficient distribution should be this along the wall, that beautiful curve right there. And drag coefficient, so the drag coefficient according to this, go to my report definitions. This is drag force. Okay, wait, this is drag force, so I'm gonna do drag coefficient along the cylinder wall. What? That's not what I wanted. The actual data is going to be calculated in the report, the drag coefficient of the circle, but this is just what it gave me. Oh, this is my reports. Here you go. But we'll use the drag force and use the formula to solve for drag coefficient at the circle because Fluent won't give us the accurate result as well as pressure coefficient distribution plot. Just for the purpose of the video showed what it gave us on Fluent, but that is not obviously that isn't accurate based off this is using our inlet velocity, but we actually want to use our test velocity. But yeah, that should be the end of part B. There's nothing else to show. We showed all the contours, show all the pressure coefficient plots. In the report, we'll have the more accurate data through Excel and the drag coefficient through as well through Excel. Could show my my drag force right here from the cylinder wall. Should print out. This is my drag force. But yeah, that's the end of this video. Thank you so much for watching.